Hi, my name is Hamza, and today I'm going to teach you vascular distensibility. So, when we talk about vascular distensibility, the first thing is that we should know what is distensibility. So, as I'm giving an example here, I'm drawing a heart. Like this is a heart, and this is aorta. So, what exactly is happening that if I assume that here the pressure is 120 and this pressure is running towards the aorta, so what is happening that if in diseases or in pathological conditions this 120 pressure goes up to 160 sometimes, and this aortic wall have to stretch, that is it has to increase its volume so that it can accommodate the volume of blood that is coming from the heart. So this stretching of the blood vessel is called distensibility, whereas in some conditions it has to compress. Like in this condition it's expanding, whereas in some conditions it contracts much, compresses. So this is how distensibility works. Now when we talk about vascular distensibility, all blood vessels are distensible, but the most distensibility is found in veins. Veins are the most distensible because they can accommodate a large amount of volume because of the large space as well as because of their capacitance, which I will be teaching forward. So now when we talk about vascular distensibility, so vascular distensibility equals the increase in volume as well as increase in pressure divided by original volume. So now how can we take out the vascular distensibility according to the percentage? I'll be showing. Wherever the pressure is more, the vascular distensibility is less, whereas wherever the volume is more, the vascular distensibility is more. That is the relationship between vascular distensibility and the increase in pressure as well as increase in volume. Now if I assume that if I increase 1 millimeter pressure in the blood, for this 1 millimeter what I'll achieve is that 1 milliliter volume will go up for 1 millimeter Hg. So I'll divide it with 1 millimeter, and the total volume is around 10 milliliter if I assume. So this is 10 the volume, total volume is 10 milliliter, and there is a 1 milliliter increase in the volume. So what I have done is I have increased 1 millimeter pressure. So now the value that we'll get over here is around 0.1. That is the vascular distensibility. Vascular distensibility is most probably taken out in percentage. So we'll divide it with 100 and we'll get about 10%. So now we can say that the vascular distensibility in these measurements is 10%. Whereas now I'll be teaching the distensibility comparison. Now we'll talk about vascular distensibility comparison. So veins are 8 times more distensible than the arteries. This, how I will explain, is that here I have taken measurements that I increased pressure up to 1 millimeter in the arteries. So what measurement of volume will I get? It's 1 milliliter. The arteries will expand to such an extent that it can occupy 1 milliliter of the blood when I increase 1 millimeter pressure in the arteries. Whereas if I increase the same pressure, that is 1 millimeter Hg in veins, so the veins will be distensible around for such an extent that it will occupy 8 milliliter of volume for the veins. Like I'm going to show you over here that if I have increased 1 millimeter Hg pressure in arteries, so what exactly is happening? Only such an extent of expansion will take place that it can occupy only 1 milliliter of the blood, whereas the same increase of 1 millimeter Hg in the veins will occupy around 8 milliliter of the blood. So this is how how the veins are 8 times more distensible than the arteries can be explained. Now I'll talk about the pulmonary veins and systemic veins comparison, whereas pulmonary arteries and systemic arteries comparison. Here you can see that pulmonary veins distensibility is equal to the systemic veins distensibility, but the pulmonary arteries distensibility isn't equal to the systemic arteries distensibility. Why is it so? Because you can see that there is right ventricle. Here you can see that there is a right ventricle. It is 3 times thinner than the left ventricle, whereas when we talk about left ventricle, it is 3 times thicker than the right ventricle. So what exactly happens is that pulmonary arteries are directly proportional to the volume and inversely proportional to the pressure. So now when we talk about volume is always equal throughout the cardiac cycle, whereas when we talk about the pressure, it is the only thing that is changing when we talk about vascular distensibility. So the pressure is more in the left ventricle because it's 3 times thicker, and it can pump the blood up to 120 millimeter Hg, whereas when you take a look to pulmonary arteries, the blood from the pulmonary arteries travel in a pressure of 25 millimeter Hg. So now you can compare 25 millimeter Hg to 120 millimeter. It's 1 over 6 times. 1 over 6 times. It's the pulmonary the aortic pressure. The aortic pressure is 6 times more than the pulmonary arteries. So now what is taking that as the pressure is inversely proportional. If the left ventricle has a pressure 6 times more, so it volume is the same. It is 1:6 in the pulmonary arteries. Now we can say that this is the reason, because the vascular distensibility in the pulmonary arteries is more than the systemic arteries.